from rational functions, and you will be able to use properties to graph these rational functions. So you need to know everything that we did last week in order to graph these, okay? Because basically, we're going to find it, put it onto a graph. Simple as that, okay? So again, when you graph rational functions, you need to make sure that you have all the information about your intercepts, your asymptotes, and your holes if there are any. Now, does anybody remember what I said last week about horizontal asymptotes? They can cross or they can touch, okay? Remember, horizontal asymptotes describe your what? Your end behavior. So do realize that it will cross. And yes, say your horizontal asymptote is y equals 2. When you do your end behavior, you will still put the limit as x approaches infinity equals 2, okay? So just cross over and continue to get really, really close. So let's go. We're going to graph this. So first thing we need to find is what? Domain. And Bethany, how do we find that? We set the denominator equal to 0, and when we do that, I get 3. And so my domain is everything but 3. And I'm going to go ahead and write that in set notation because it's easier that way. X is the element of. Now don't get me wrong. If you want to write an interval notation, by all means, do you, boo-boo. Do you. What's next? The holes. Do we have any?
No.
How do you know, Isaac?
Because there's no x plus 4 on the bottom, there's no x minus 3 on the top.
Because there's no x plus 4 on the bottom and no x minus 3 on the top, which means nothing cancels out. So yes, we have no holes. Okay, so Chris, what's next? Vertical asymptotes, okay? So how do I find my vertical asymptote?
You said the denominator equals 0.
I set the denominator equal to 0, so x equals 3. That is my vertical asymptote. So when I draw that means that at x equals 3, there is a dotted vertical line that the graph will not cross nor touch. What's next? John, what's next? And what is the horizontal asymptote? How'd you get, careful. Not just one, but. Say again. Y equals 1. And how'd you get y equals 1? Look at the degrees. They're the same. They're both 1.
You look at the leading coefficient.
So then you look at the leading coefficient. So y equals 1. That's a horizontal line that crosses the y-axis at 1. Question.
How would you write the intermediate about letting go? The vertical asymptote.
Well, see, with your vertical asymptote, the curve is going to approach it, but never cross your vertical asymptote. And so technically, that's not going to be in the end behavior that we know of. That's just more specifically what's happening as x gets closer to that number. End behavior, no matter what, is as x gets bigger towards positive infinity and as x approaches negative infinity. So that would be something different than when more specifically as you're approaching your vertical asymptote. What we got left, Kim? And how do I find those?
Put 0 here for 1. Or set the
Which one?
Oh,
For x-intercept, which one am I going to do? Numerator equal to 0. There you go. Because remember, if you got to find x, you can't plug in 0 for x if you have no more x's. So what's my x-intercept? That number, which is? Negative 4, 0. It's always a point, right?
Yes.
Are there any questions so far? Am I going too fast? I've got a lot of energy. So let's plot that point. And I'm hoping the colors are helpful so you won't have any confusion of where this information is coming from. Last thing I need to find, Brian, is my y-intercepts. And how do I do that?
Plug in 0 for x.
Plug in 0 for x. So when I do that, I get 0 plus 4 over 0 minus 3, which is negative 4/3. And I write that as a point.
0.
All that work. And so then once you do that, you have all your information. Questions up to here? So, your curve needs to cross through those x and y intercepts. And if you think about it, a rational function is going to kind of look very similar to your reciprocal function. You guys remember what those look like? It has the branches. So your first branch is going to be right here. It's going to come through -4, 0, 0, 4/3, and it's going to approach that vertical asymptote, not cross, not touch. And it's going to get closer to your horizontal asymptote as well on the other side. So as you're drawing this in your notes, please make it a smoother curve than what I just drew.
No promise.
No promises. But there's your first branch. Now where do you think the other curve is going to be?
On the other side of the horizontal.
Oh, up, over.
Like top
No,
left,
the other side.
top right. It will be over here, top right. Now, if you don't believe me, you could always plug in a point to the right of the vertical asymptote, such as 4. Okay? When I plug in 4 into that equation, I'll have 4 plus 4 over 4 minus 3. What's 4 plus 4? And 3, 4 minus 3? So the point 48 is a point that's on my rational function, which is right in this area. So yes, here is the other branch. It's going to approach that vertical asymptote, not cross, and it's going to approach the horizontal. And there's your rational.
Do we need to graph the other side?
Yes, you do need to make sure that you graph both pieces to your rational function. Yes?
Does that have to be like too accurate? Can we do like loosely written like that?
Yes, you could do it loosely. The one thing though is that the ones that do have the x and y intercepts, they should go through those points, but the other one can be a loosely drawn curve.
Wait, so how did you get the other one?
This curve up here?
Yeah.
Well, we knew that was going to be opposite of this curve here, but to confirm it, we picked a point that was to the right of the vertical asymptote, which was 4, and we found this corresponding y value. That's how we knew it was up there.
Could it be any number to the right?
It could have been any number to the right. Just realize the bigger that x gets, the closer the number is going to get to what? 1. The horizontal asymptote.
So now we're going to start dropping down.
So then end behavior should be
If I asked you what the end behavior would be, you would tell me the left and the right side would both be the same. It's approaching what number? 1, the horizontal asymptote. Because the bigger that x gets, closer it gets to 1. To negative infinity, the closer it gets to 1. That's that. Okay? Here's the next one. Alright, let's bang it out. Find the domain, Cody.
you said the denominator is equal to 0.
So x equals,
-3.
so the domain is everything
5.
but -3. X is the element of all the numbers. Cool deal.
And we gotta find the holes.
I gotta find the holes to list like I need.
No,
No, why?
I don't think you can't cross anything out, nothing crosses out.
Nothing cancels out, so I have no holes. Okay? After that is fair game. Is unique. Give me something. So the denominator equal to 0, so my vertical asymptote is awesome. Nick, give me something.
The X-intercept is 6, 0.
Careful. To find the x-intercept, we would set the numerator.
Oh, equals, okay, yeah.
And what does that mean?
You don't under.
So it doesn't have x-intercepts?
So it's not going to cross the x-axis. Because there's none. Because 6 equals 0 is nothing. We got to have a variable there in order for it to be something.
What do the horizontal asymptote?
Yep, we still need to do that. Horizontal asymptote.
There's no exponent.
There's no exponent there, which means
Y equals 0.
it's going to be y equals 0. If there's no x up here, that basically means that the exponent was a 0. So the denominator is still bigger than the numerator, so my horizontal asymptote is y equals 0. Last thing we need to find are my y-intercepts. Chris?
0 for 3. Would you put 0 for that?
Plugging 0 for x. And that will be 6 over 3, which is 2. So 0, 2. Questions up here? It's time to ask them. Where's the first branch going to be? Top left, top right, bottom left, bottom right. Top right is going to cross through that y-intercept, be close to your vertical asymptote. Same thing with your horizontal.
Question, how do I know which side to go?
No.
Because it has to cross through your y-intercept and your x-intercept. If we have one, but since we don't have one, we knew it had to cross through that y-intercept.
In this case, how would the opposite just be -2
What do you mean?
for the y-intercept? Find the other half.
To find the other bit?
Wouldn't it be -2? 0, -2.
It's not, in this case, it's not going to end up being on the same side. It's going to be in the diagonal, across.
So it's always diagonal.
It's going to be diagonal when you have your two, when you have a horizontal and vertical asymptote. Thing is, if you ever questioning where the other piece is, you can always plug in a point to the left of the vertical asymptote or to the right, depending on what. So if I plugged in -5, this would be 6 over -2, which is, so it would have to go through that point. Yes.
And whenever we have a hole, we just circle.
Skip right over. Yep. Questions up to you. So go ahead and make this change onto your notes, okay? Make this change here. I'm trying to give you one of each type. So, you won't be like, wait, what am I doing on your homework? Brianna, how do I find my vertical asymptote? Domain. That's what I'm going to say. I'll find my domain. Set the denominator equal to 0, and I get 1. So my domain is everything but 1. And yes, I have no holes for the next one because nothing cancels out. I think the next one has a hole. Where's my vertical asymptote? Anybody? X equals 1. Horizontal asymptote. I don't have one because my numerator is bigger than my denominator, so it's a slant. How do I find it? What goes in the backwards L? 1. It's always the opposite of the denominator. What goes to the right of it?
1, 0.
If nothing cancels out, if there are no holes, you use the original. Okay? So synthetic division, bring it down. I have 1. 1 times 1 is? 0 plus 1 is? 1 times 1? We don't care about that -8. All I care about is this part right here. And that is our oblique asymptote. We started with a quadratic, so then we ended up with a linear. That's what that is. Let's graph this real quick. Where do I start? 1. What's my slope? Up 1 over 1. Or
Down 1 over.
down one left.
And then there's the vertical asymptote.
Yep, gonna get that in a second.
Ooh, question.
It could be a line, it could be quadratic. So then you write that one.
Like the horizontal asymptote, can it cross the weak and touch?
Honestly, in my years of dealing with these, I've never seen it actually cross a slant asymptote. I've only seen them cross your horizontal ones. It does have to be a dotted line, just like your vertical asymptote is a dotted line. Please make sure it's a dotted line, not a solid. If it's a solid, you're going to make me think that it's a part of your curve when it's not. Okay, so all asymptotes are dotted lines. Yes?
So which one is that?
The pink one is our oblique asymptote.
So we got an x plus 1. How do you graph it? I mean, how do you?
You start with, this is basically in slope-intercept form. So you start with your b, which is where it crosses the y-axis, is constant. So that's what we started at 1. And then our slope was 1. So from that point, we went up 1, over 1. And then we also went down 1 to the left to get the rest of the line. Yes?
The oblique will always be the same thing if it's in the L, backwards L. Or is it just coincidence this time?
You mean all ones? No, it's just coincidence time. I need a vertical asymptote at x equals 1. Do I have any x-intercepts?
Yes.
Where?
-3.
And you get those x-intercepts by
Setting numerator equal to 0.
setting the numerator equal to 0. That's where those came from. Your y-intercept? 0, 9. You get that by plugging in 0 for x. Plot all your information. Yes. Does everybody see where our two branches are? This one's actually visible to see. It's going to be right here crossing through this point of -3, 0 and crossing through my y-intercept of 0, 9. Does everybody see that one? Okay. It's going to get really close to this oblique asymptote and my vertical asymptote. And the other one is going to cross through that other x-intercept at 3, 0. You get really close to the oblique asymptote and to the vertical asymptote. Okay? Domain is already in factored form. To find the domain together. Okay, I only have like a handful of people. That's okay. Said what? The denominator. So x is going to equal
-3
so my domain is everything but those values. Remember, again, we get that by setting the denominator equal to 0. There are no holes, nothing cancels out. The last example does give you a hole so you can see that. So please make sure you watch the video. It's an extra one that's not on there, so you have to add it in. I have two vertical asymptotes here, don't I?
Yes.
X equals. So I got two vertical asymptotes here. have a horizontal asymptote of y equals 0. Because what was the degree of the denominator? 2. Because you have an x times an x, which gives you an x squared, and at the top is only 1. So the denominator was bigger, so it's y equals 0. How do I find my x-intercepts? And when you do that, you end up getting what for your x-intercept? 6, 0, which actually is going to do what? Touch it. It's going to touch that horizontal asymptote. Lastly, my y-intercept. Plug in 0. So I have a negative 6 on the top, and what's 3 times 5?
Let's give 2 or 5.
So please watch the rest of this video so you can get the rest of this. Alright, so picking up where we left off in class, we have found all this information relating to our rational functions. We had 2 vertical asymptotes, a horizontal asymptote, an x-intercept at 6, 0, which actually is on your horizontal asymptote. We had a y-intercept of 0, negative 2/5. So what this basically means is that when we graph this, okay, our curve is going to come from down here, really close to our vertical asymptote. It's going to cross over the y-intercept, and then when it gets to 6, 0, it's going to cross the horizontal asymptote, and then continue to get close or stay close to the horizontal asymptote. And I know it looks a little funky, but that's exactly what is going to happen, because remember, it can cross over your horizontal asymptotes. But here's the first branch right here, crossing over that y-intercept, the x-intercept, and then continue to have an end behavior of 0. Now the other pieces, if you notice, we have 2 other regions. We have this region in between our 2 vertical asymptotes, and we'll have the region that's on the left side of that very last vertical asymptote. So how do we figure out exactly what's happening in between? Well, we plug in points, okay? So we're going to plug in points in between -3 and -5, such as -4, maybe even -4.5, maybe even -3.5. So that way we can actually see what's happening in this curve. So go ahead and plug in -4, -4.5, and -3.5 in for x to find those corresponding y's. So when you plug these in, you got these numbers. When you plug in -4, you got 10. When you plugged in -4.5, you got 14. And when you plugged in -3.5, you got 12. So when you plot those, what ends up happening is basically on this side, you're basically going to have kind of a funky looking parabola that is going to cross through those points and curve back up and be bounded in between those vertical asymptotes. Okay? So if I were to extend these, you would see that again it would get very close to those vertical asymptotes but not cross or touch. Lastly, what's happening on the left side of this vertical asymptote? Let's plug in -6 and see what happens. Well, -6 minus 6 over -3 times a -1. That's a -12 over a +3, which is -4. So at -6, we're at -4. And so this graph, or this part of the graph is going to do this number here. I know it looks a little weird, a little strange, but yes, there are some rational functions that will look like this, especially when you have 2 vertical asymptotes. Now, there's one more example that I want to do for you guys, which is right here. Let's go ahead and let's change this to a -1. It wasn't in your notes, so I need you to add it in there. We're gonna find the domain. By doing that, we set the denominator equal to 0, so we'll get x equals 1 and x equals -3. Which means my domain is everything but those two values. And x is the element of all real numbers. We'll need to find our whole after that. We'll see that x minus 1 cancels out. So then we're left with 1 over x plus 3. To find our whole, we set that canceled out factor equal to 0 to get 1. And when we plug it in to our simplified form, our whole will be at 1 and a 1/4. So that literally means that at 1 and 1/4, we're going to have an open circle to represent our whole. To find our vertical asymptote, we're going to set our simplified denominator equal to 0. So we'll get x equals -3 as a vertical asymptote. To find our horizontal asymptote, we look at the degrees. We'll see our denominator is bigger than our numerator. So our horizontal asymptote is y equals 0. We need to figure out if we have the x-intercepts by setting our numerator equal to 0, which can't be possible, so we have no x-intercepts. And lastly, our y-intercept, which can be found by plugging in 0 for x to find a y-intercept of 0, 1/3. Our first branch of our rational function is going to be right here in this top right area, where it's going to go through our y-intercept. It's going to skip over our whole, but continue to get closer and closer and closer to our horizontal asymptote. That's how you draw it if you have a whole. And our last branch is going to exist in our bottom left corner. But if you don't believe me, again, you can always plug in a point that's to the left of that vertical asymptote, such as -4. If I plug it into my simplified form, I see when x is -4, y is -1, which is indeed in that bottom left. So go ahead and give your homework problems a try. Bring your questions tomorrow to class.